All right, 9-7, factoring special products. This is our last set of notes on factoring. We have one more set of notes for this unit, and then we will be taking our quiz on our last half of Unit 9. All right, so factoring differences of squares. So when you have a term, a binomial, that's a squared minus b squared. You can break that up and factor it into a plus b and a minus b, or a minus b, a plus b. It doesn't matter which one goes first and which one goes second. And we have an example. X squared minus 9. Well, x squared can be broken down to x times x, and 9 can be broken down to 3 times 3. And so that'd be x plus 3 and x minus 3. Now we need to make sure when we are factoring, we factor all the way down. So sometimes you'll factor the difference of a square, and one of those factors will still be a difference of a square, and so you'll have to factor it again. Now on your assignment, and we're going to cover that in this example here, and on your assignment, it may ask you to factor by grouping first, and you'll know that because you'll have 4 terms, and you'll need to factor by grouping, and then one of those factors that you did when you factored by grouping will be the difference of the square, and that will need to be factored again. So remember, ask for help if you need it. The assignment is in McGraw-Hill, and most of it, the answer choices are there, and you slide it up. But you have to make sure you have all of the factors out of the term you're given. So let's practice it. All right. So we have got, 121. All right, in order to be a square, and difference of a square means we got minus signs, so if the minus signs and around the minus sign are perfect squares. So to be a perfect square, it has to have a number times itself, be 121. Well, what number times itself is 121? 11. 11 times 11 is 121. Then we have x squared. X squared breaks down into x times x. Then we have 36. 36 breaks down into 6 times 6. Okay? So we're going to break this down. We're going to break this binomial down. We're going to factor it into 2 binomials. All right? So 11x. Okay. First term, 11x. And then we get a plus and a minus. One term has a plus, one term has a minus, and they each get a 6. And what you can do if you're like, I'm not sure if I'm right or not, you can factor it. Okay, you can FOIL it. So you're going to check your answers. You can use FOIL. Okay. So we have got our first, 11x times 11x is 121x squared. And then we have our outside, which is a minus 66x. We have inside, which is a plus 66x. And then we have our last, which is minus 36. Now what you'll notice is we have these 2 terms on the inside, minus 66x plus 66x. And what these center 2 terms are, are what we refer to as a 0 pair. We've come across 0 pair before, but really what they do is they cancel each other out. And so you take them out because they're a 0 pair, and you end up with that 121x squared minus 36. And is that where we started? Yes, it is. Okay, so let's practice that again. Okay, So 400 g squared minus 49 h squared. Well, we can break these perfect squares up. So 400, that breaks up into 20 times 20. G squared, well, that's just g times g. Okay, that's our whole first term, broken up. And then our 49h squared, well, 49 breaks down into 7 times 7. And h squared breaks down into h times h. All right, so we've got this binomial. We're going to break it down into two binomials. So 400 g squared breaks up into 20g and 20g. One set gets a minus, one set gets a plus. And then my second term, 7h and 7h. All right, we're going to do that one more time. All right, my first term, well, there's no number, it's x squared. So x squared broken down, x times x. And then 10,000 broken down, well, that's 100 times 100. So we factor that. And each factor set gets an x. One is a plus, one is a minus, and then 100 goes into each. All right. Now we're going to do this one. Okay, this one we're going to be able to factor more than once. All right. So I have got z8. Well, that breaks into z to the fourth and z to the fourth. And then 1 breaks into 1 times 1. Okay. So we start with a z to the fourth in each, a plus, a minus, and a 1 and a 1. Okay. Well, this second factor here is also the difference of squares. So we can factor this one again. So z to the fourth breaks down into z squared times z squared, and 1 breaks down into 1 times 1. So we keep this first factor of z to the fourth plus 1, and now we have two more factors. It goes in a z squared and a z squared. Get a plus, get a minus, 1, 1. Now again, we have differences of a square. We have the difference of two squares. So we can factor that yet one more time. So z squared. Well, z squared factors out into z times z. And 1 is still 1 times 1. So we're going to keep z to the fourth plus 1. And we're going to keep z squared plus 1. And we're going to factor this difference of squares. So we'll get 2 more factors, which would be z, a plus, a minus, 1, 1. Now this is no longer the difference of squares, so this is our final factorization. And yes, you must fully factor it. Your problem will tell you it is wrong and not correct if you haven't fully factored it. So make sure you fully factor all of the differences of the squares, all right? It's going to happen quite a bit. Okay, so we've covered that. Now, let's cover this in actual process of a real world scenario. So we've got Leah is crocheting a square. Okay, so she crocheted the square that will be used to make a blanket. Go, Leah. The center square is 6 inches wide. All right, so if we are 6 inches wide, it's a square. So that means the length is, well, also 6 inches. All right, so this is a 6 by 6 square. In the center, that's crocheted. Okay. Now, she plans to use blue yarn to make a border, okay, and it makes the square X inches wide. All right. So after she adds the border, this square is now X inches wide. Well, it's still a square. So since it's a square, if we're X inches wide, then we're also X inches in length. Okay, and this is the measure of the whole thing. The whole thing. The inside with the border equals an X by X square. What does it want us to do? It wants us to factor the expression that represents the area created just by the blue yarn. So it wants just the area of the border. All right, just the area of the border. Well, to find area of a square, you've got length times width. All right, well, we have this larger square, and we want the measurement of the border, and we got to take out the area of the center square to get just the area of the border. So we're going to subtract. So outside, so the outside measure with the border yarn is X times X, which equals X squared. Now the inside crocheted squared well, what's its area? Well, it's a 6 by 6 or 36. So we have got, we take the entire finished piece of X squared minus the crocheted inner piece area, okay, and that will give us the area of just our border. Well, we have the difference of squares, so X squared is X times X. 36 is 6 times 6. So when we have the difference of squares, you have, okay, each factor gets an X, one factor is plus, one factor is minus, and each factor gets a 6. So we factored the expression that represents the area created by the blue yarn. Okay. Now, one of the things we need to do, and you'll have a question on the test. It's worth 4 points. It'll be one of the highest points because it has different pieces to it. So you need to be able to identify perfect square trinomials. Okay, perfect square trinomials. And what it is you got a squared plus 2ab plus b squared. All right, and that equals a plus b squared, because it's a plus b times a plus b. So you have a plus b twice, which would be ab squared. Or it's a squared minus 2ab plus 2b squared, where you end up with your factor as a minus b squared, because it's a minus b times a minus b. All right, and we got a couple examples here, okay? So we're going to determine if these are perfect square trinomials. All right, we're going to determine if they are perfect square trinomials. And we'll use that FOIL method again, okay, to check. So we just need A and B. All right, so A is 100, and that breaks down into 10 times 10. And then B is 64, and that's 8 times 8. Now, if this is a perfect square trinomial, we would be able to set up, whoopsie, plus plus, all right? We would be able to set up our factors. Oh, wait, x squared. Okay, x squared, x times x. So our first term factor is 10x, and each factor gets a 10x. Now these are plus plus, okay? So we're trying to get perfect square trinomials, so both factors need to be plus. And then each factor also gets an 8. Now we're going to check with FOIL. We're going to go backwards, and if this indeed is, because this would, your answer would be 10x plus 8 squared. If this is the factor answer to that, then yes, this is a perfect square trinomial. But if we use FOIL and we do not get back to where we started, it is not a perfect square trinomial. So first, that would be 100 x squared outer plus 80x inner plus 80x last plus 64. Your two terms in the middle, we're going to add them. That's 100x squared plus 160x plus 64. Is that where we started? No, it is not. Okay, so this is not a perfect square trinomial. It is not a perfect square trinomial. Okay. Now let's try one again. Okay. So it's a trinomial, and it's got a minus and a plus. So that means our if this is true, then when we end up factoring it out completely, what it should look like is A minus B squared. That's what it should look like. Let's see if it ends up being that way. All right, so y squared, that's my first term, that's my A. Y times y. Well, A technically is 1. Y times y. 121, 11 times 11. Okay. So let's see. They both need negative signs. So y minus 11. Let's use that FOIL method. Let's see if we can get from here back to there. So first, y squared. Outer minus 11y. Inner minus 11y. Last minus, well, plus 121. Center two terms. Y squared minus 22y plus 121. Did I get back to where I started from? I sure did. So therefore, y minus 11 squared is the factoring of y squared minus 22y plus 121. All right. Now, again, when we were doing this class, everyone was like, oh, this seems so easy. And it is, but when you do this skill in conjunction with other skills, you really have to think, all right? When you have to factor, okay, the difference of a square, when the factor ends up being the difference of a square and you have to factor them again, this really caught and threw people's minds off. When you have to factor by grouping, that threw people's minds off. I had to tell several people, get your notes out. We factored by grouping. It's in our notes. You need to know how to do it. And so step one was factoring by grouping. And then one of those factors was the difference of a square, and then you had to add this skill on top of that skill. So reference your other notes, give it a try, write things down. My students who struggle the most refuse to write things down and try to do everything in their head, and they are definitely riding the struggle bus. All right, this assignment done, and good luck.